Welcome to this class. We're going to be talking about big data and Hadoop. In this class, we're going to be talking about what big data is, how Hadoop is used in big data, HDFS, which is short for Hadoop distributed file systems. We'll be talking about how we use MapReduce programming, advanced MapReduce concepts, and we're going to be having some hands-on. So let's get started with big data, the word big data. So big data refers to data that comes in different forms. When we say big, the word big enough is to tell us that the data is in a very large quantity, and it has different forms. So basically there are 5 V's that we use to define the characteristics of big data. We say big data is large, that's the volume. I'm just going to change this color to white. So we have 5 V's. So we have V, which is the volume. So this tells you that the data is large. It's in terabytes, gigabytes, and in a very large form. So it can consist of social media files, transactional records, census data. Think of Amazon transactional files, how large it could come in form of. So the second V we're going to take a look at is velocity. So velocity means the speed, right? So which means data that can be processed in a very fast and unprecedented speed, which means data that can give you real-time updates. For example, now if let's say let's take a case study of working at Amazon, and every time every time we buy something on Amazon, there's a system that gets the transactional log files of what we have gotten, where we are, and that's our location, the products that we have purchased, our credit card details, and all of those other things. So imagine a system that is processing such information within microseconds. So which means that the data is, of course, very fast. So the third V we're going to look at is variety. So as big as Amazon is, we cannot expect that they're going to have, or they're going to be working with structured data. Now let me give you a case scenario of what Amazon data typically look like. So they have a database that stores the user information. All right, they have a database that stores the transactional files. They have a database that stores your products, the products that they offer. They have a database that stores that process the delivery and how these products gets to us. That's the logistics. So imagine Amazon is processing all of this data within milliseconds, which means I'm buying here in the UK, you're buying here in Nigeria, we're all buying from different areas, and Amazon is able to process those kinds of information at the same time. So the third V we're going to look at is the veracity. So we've talked about data coming in different forms, which means that they are going to be working with different kinds of files or database files. So we want to talk about veracity. So veracity refers to the reliability of the data. For example, say veracity. So veracity, which means that the accuracy of your data, it's not consistent, it's not structured. back in the day we used to use SQL to define our database structure, because we believe that our data is always going to be structured, right? For example, if you wanted to create a database around a transactional file, we would have some tables having your user information, your location, your demography, and stuffs. So we say this kind of file, this kind of database can possibly be a CSV file. Now, your user information too can be a CSV file. Now, talk about a product. A product can have different kinds of categories, right? You can have the product category, subcategory, and then the product name, and all of this we want it to fit into the system. Now, let's even assume that this file is also a flat file, right? Now, Amazon wants to process this large data set. We also want to say, okay, fine, we have a database that is in that the logistics, the transactional logs, where we can process what product goes to what location and stuff. So now the logistics part will then include maybe a JSON file or an XML file or something like that. So we want to process all of this data into one central place, right? The knowledge of SQL alone is not going to be able to do that, because we would basically be working with different kinds of files, and our data is also in a very large form, which means we cannot use the traditional database management system that we have been using, because this is going to be very slow when it comes to the execution part. So the last field that we're going to look at is value. So value includes getting insight from your data and using that as a lead to getting business intelligence and innovation from all of this that we've mentioned before. So think of all of this now. This defines the kind of uniqueness that comes with having a very big data set. So when they say data is big, it means it has a very large volume. It comes in different forms. That is the variety. It could be a text file, it could be images, it could be videos, it could be a web blog file. So we say it has a velocity, it's fast, which means it has a very high velocity, and then it has value. So why are we talking about big data? What's the importance of big data? We use big data for business insights. We use that to enable organizations to derive meaningful insights and actionable insights from their log files, from their present data, from the present data that they have. So we use it to make better decisions, data-driven decisions, and we also use it to understand the customer behavior. Now, if you agree with me, if you shop on Amazon, let's say we go on window shopping on Amazon, and you are fond of checking the particular product every now and then, with time you'd realize that Amazon will start sending you products that are in the same category of product that you've been checking out. So this allows you to understand. This allows business owners to understand the market trends, what their users are viewing, what their users are interested in what location their users are viewing them from, and a couple of other things that are so interesting about this. So it brings about innovation, because big data fosters innovation by uncovering patterns and trends that leads to development of new products, services, and processes. So we use big data to our advantage, which means we can use it to understand the trends in the marketplace. So this in turn gives us keep us abreast of things, the change in the trends in the market, and how we can use that to our own advantage. So one of the other things that big data does for us is that enhances operational efficiencies. You are able to allocate your resourcing to the right place because you are able to get insight from what you are, what your company serves, or what you, the kind of value that you post to have. So the challenges of big data would include how you want to manage the kind of volume of data that you handle. So imagine you're handling a terabyte or 250 terabytes or gigabytes of data. You can't run that on your own local machine because this could take like forever before if it doesn't even crash the system. So the challenge of big data is having an operating system or a system that can help you manage the kind of data that you perceive to want to manage. And then the second challenge that big data has is the velocity, which means working with a continuous flow of data. Think about this when you are trying to check the global stocks, or for some of us that are into NFTs and cryptocurrencies and stuff. You want to check the blockchain. You want to see what coin or what crypto coin is it's on the high side, or the one that's taking a dip. So this helps you to, these are the kind of problems that big data solves in real time. So the other problem that big data is facing is variety. Just like I said, data can come in different forms. You can imagine you are operating in an environment where you have to work with different kinds of data. For example, I've used Amazon as a case study where you'd have to use you have databases that stores CSV files, for example, for our products. And then as our products keeps increasing, the problem keeps increasing also because we have a structured database. So if we wanted to build a system around something that could eventually increase with time, then a structured database will not do the trick. So data security and privacy, how do you want to actually keep abreast what security it needs to keep this big data in check? Because you can the fact that as the data keeps increasing, the threats to that data also keeps increasing. So you need to put that into consideration to ensure that your data is in safe space. So the opportunities that we can explore in big data, you can use it for predictive analytics, such as when you can say, okay, fine, we have this bank of data somewhere, and this is our present data. You can use it to make predictions of what our yearly income is going to be like, what our monthly income is going to be like. And we can also use it to personalize user experience, just like that we see on Amazon and Netflix. If you observe how their system is being structured, you see that when you browse a particular genre of movie, it tends to give you a return of suggestions of movies that you've not seen that you can also watch and enjoy. And then on Amazon, it gives you a suggestion of products and services, or products that you might want to be interested in based on your search history. So why are we learning Hadoop, or what exactly is Hadoop? How does Hadoop actually come into play in all of this? So Hadoop is actually an open source framework that is designed for storage and used to process large data sets which are distributed across clusters of computers. Now imagine you wanted to create a database for an e-commerce company. So you'd have to separately create a database for their products. You'd have to separately create a database for their transactional files, and then you'd have to create another database for probably the logistics part of the company. So as your data keeps increasing, it becomes increasingly challenging to maintain that kind of database, because you're going to spend more maintaining this kind of services as a company keeps growing. So Adobe is an open source framework that allows you to to run your data or to work with data across clusters on computers. So before now, it was the evolution of Adobe was that it was originated in 2005, and it was usually called a project called Apache Notch, which is a web search engine, and it was inspired by Google MapReduce and Google File Systems. So it was later named by Toy Elephant, which is in the year 2006 to Adobe. So Toy Elephant is a son of Doug Cotton, and it became Apache product in 2008. So you see that far from Apache is not as old as data itself. So the word Apache Adobe is actually the combination of three concepts, which is the file system, the process, and then the management. So which is gonna take us to three things. Just gonna make she's gonna say HDFS. Don't mind my handwriting. HDFS, MapReduce, so every time I install Adobe on my system, these three things comes inclusive with the software. Now, what's HDFS? HDFS is short for Adobe Distributed File System, which is a storage layer of Adobe which allows you to store large data sets across different clusters. So the most important thing about Adobe HDFS is that it's takes into consideration fault tolerance. So let's say, for example, I have three clusters right here, and for some odd reasons one of the clusters goes bad. Adobe is able to manage the two clusters, the remaining two nodes right here. Sorry, it's able to manage the remaining two without having to affect this other one that's gone bad. So I understand that the fact that your file is being distributed across these three nodes, right? So if this remaining two shares the data allocation for this one node that's gone bad. So this enables you to keep running your application without having to experience downtime. So the second one is MapReduce. So MapReduce allows you to process layers of your distributed data processing. So MapReduce performs an aggregation on your nodes. It allows you to process your data parallel across all nodes, and it enables you to scale. It enables scalability and fault tolerance. So the last one is Yarn. This one right here. So Yarn is a resource management layer which allows you to process multiple engines to share resources. So it enables you to efficiently resource utilization and support various processing models. So we have some other resources that we use apart from Yarn. We have just like we've said, we have Yarn is used for resource management. So we have other ones like Apache Hive, which provides a data warehouse and an SQL-like interface where we can run our data like we're running a database system. And then we have Apache Pig, which is a high-level platform for creating MapReduce programs, which we use for processing and analyzing large data sets. So we have HBase. HBase is a no programming database that provides real-time read or write access to large data sets. We have Spark also. Spark is a very fast and general purpose cluster computing frameworks which we use for processing big data. We have Apache Scoop. Scoop is used for facilitating the transfer of data from Hadoop to relational databases like SQL and stuffs. So the last one we have Apache Flame. Apache Flame is a distributed, reliable, and available service for efficiently collected, aggregated, and moving large amounts of log data. So we have different kinds of Apache features that we can use to enhance our data capacities and enhance the process management in Hadoop.